Okay, so today factoring polynomials part 2 or day 2. Good morning, everybody. Get your paper, pencil ready. We're going to do a shorter lesson today, just more review and more practice factoring polynomials. And then we're going to stop at 10:30 and do your mastery test for this. Any questions, concerns? All right, here we go. So example 1 for today. Factor the polynomial x to the second power minus 20x plus 91. How do we get started?
You recognize the A, B, and C.
Absolutely. Thanks, Aaron. Yeah. A is 1 still. Why is it 1? Because there's no number being multiplied to the x squared. So we're just going to call that 1. 1 times x squared. B is negative 20. And then C is 91. You might be thinking, why are we bothering with the A all the time? The A is equal to 1. It will come into play more later. So for yesterday and today, A is kind of unnecessary, but I wanted you to get used to thinking about it and seeing it because it will matter more later when there is a number for A besides 1. So once we recognize it, like Aaron said, we're going to make our list of things that multiply to A times C. And in our case, that is 91. And we'll check that against numbers that add to B. And in our case, that is negative 20. So I like to start the list at 1. 1 times 91. And then does 2 work? 2 times something, does that equal 91? To find out, divide. So 91 divided by 2. I get a decimal, so we skip 2. Try 3. 3 also gives a decimal. And go down the list, or I guess go up the list. 91 divided by 4, still a decimal. Just keep going until you hit something that gives you a whole number. All right, I got 7 worked. So 7 times 13. Now remember, this time we're adding them to a negative number. So 7 plus 13 does give us 20, right? So that seems like we're on the right track, but it doesn't make 7 plus 13 doesn't equal negative 20. So we have to do a little detective work here and think, well, how can I make 7 and 13 when I add them together equal a negative 20? If they were both individually negative, negative 7, negative 13, and that works. Those equal negative 20. And when I multiply negative 7 times negative 13, they multiply to a positive 91. Perfect. So that's our configuration, our grouping on how we're going to split up B. So back to the actual problem now that we've got our negative 7 and negative 13. Can anyone tell me how we or what we should do next now that we found this -7, -13. How do we use those?
Don't you put it in the place in between the x to the 2 and the 91?
Yeah, absolutely. Can I ask you, what happens to the -20? Should I write that as well, or does that go away?
No, because the 7 and the 13 make it up.
Perfect. Thank you. The 7 and the 13 make it up. So I'm going to write my -7x. Don't forget the x, and -13x. Okay, it's pretty much downhill from here, except you might wonder, does it matter if I put the 7 first or the 13 first? Like, does it matter which order I write these? The truth is, it doesn't matter. It should still work either way we write it. Then we want to factor the two left numbers and the two right numbers, the front half and the back half. Just like all of our examples so far, we're always going to be able to pull out an x from the first set. I can pull out a single x, and it looks like that's it. And we're left with x minus 7. Now, over on the right side, I want to pull out as much as we can. However, it looks like it's going to be a little different looking. Like if I pull out, let's see if we can divide 13 from both of these. We can divide 13 from itself. Very good. And we can divide it from 91. Yes. So that's good. So it looks like we'll pull out 13. But notice that if we just pull out 13, then we'll have -x plus 7. And we want it to be x minus 7. So this is a little more detective work, a little more forward thinking. We have to not pull out 13. We're going to pull out -13. And by dividing both of these terms, the 91 and the 13x, by -13, it's going to switch the signs and get us the result we want in our parentheses. And now, if we were to pull out or factor out the x minus 7, what's left over there? X minus 13. So that gets its own parentheses for our final answer. X minus 7 is factored out, and what's left is x minus 13.
You know what I realized?
Yeah.
If you just, since you already got the factors when you did it up there, you technically already have the answer. But it's like doing the math part in between.
You know what, Aaron? That's totally correct. We basically have the answer way back here, right?
Mm-hmm.
Yeah. And then I want you all to understand what we do with those. Where is this coming from, our final answer, in relation to what we got back here in our list? So, as long as you see that and you're comfortable with it, you are totally good to, at this stage, the -7, -13, just use those for your final answer. And you can kind of skip this middle work. So yes, you're right. Yeah, we get our answer back there. Now, later, when our A is not 1, then things will be a little more tricky. And I think doing these middle steps will be more important. So, but for these simpler ones, when A is 1, yeah, you could basically just say, okay, x minus 7, x minus 13, we're done. Let's try another one. Example 2, x squared plus 6x minus 16. Now remember, if the C number is negative, that means when the two binomials multiplied together, one of those was negative, one was positive. A is 1, B is 6, and C is negative 16. So our list now, one number negative, one positive, multiplies to negative 16, adds to 6. When I'm making my list, because of this issue of one of the numbers being negative, I just multiply them as positives, at least to begin. Like 1 times 16, 2 times 8, 3 doesn't work, 4 times 4 works, and that's it. And then I start playing around with these sets that I just made to figure out which one would need to be negative for this to work. Also, you might be able to see the difference you need just looking at the two numbers. So the difference between 1 and 16 is 15. That's too big. We want it to be 6. The difference between 2 and 8 is 6. So right now I know this is the right mix. And then we got to figure out which one's negative. So you can do it in your head, or you can do it on some work to the right. Negative 2 plus 8 or 2 minus 8. We're trying it out both ways with one of them negative each time. And the first one gives us the positive 6. So we'll make our 2 negative and our 8 is positive. So based on what Aaron pointed out for the last example, what she's saying is we can kind of, at this point right here where we identified negative 2 and 8, we can skip right to this. X minus 2 times x plus 8. Let's just, instead of working backwards, let's just double check this. Let's multiply these out like we learned to do earlier and see, does that equal what we started with, the whole polynomial? X times x, x squared, x times 8, plus 8x, negative 2x, negative 16. Looks good. So this worked. So checking the work, it shows, yeah, we did find it, and we skipped a couple of those factoring steps. Feel free to use that shortcut. But I think next week when we start the next level where A is not 1, then I think we will need to do the middle steps. But we're totally allowed to use this shortcut in the meantime. Any questions? Any questions on this shortcut that we did here where we kind of skipped the middle steps? Okay, let's do this. Yesterday we did a whole bunch of examples like this. Today we've just done 2 so far. Let me see thumbs on how people are feeling so far. Yesterday and today's work, factoring polynomials. Thanks, Aaron. Thanks, Manaya. Braden, thank you. Thanks, Delaney. Keegan, awesome, thank you. Sai, how you doing? Bailey? Okay. You guys there? Let's try a few more. And I want you folks to help me out with the next one. We're on number 3, right? Number 3. Now, usually I don't like to call on people and put you on the spot. So I guess I won't do that now still. Because the goal isn't to make you feel bad at all. The goal is just to work with you on it. And that's all I want to do. But So that's all. That's the only reason I would want to call on individuals specifically instead of just asking for who's ready, who's comfortable. So I guess I'm not going to do that still, but I really want to encourage you all to work these out with me. I hope you're all taking notes and following along for each example because it will make a huge difference. Okay, example 3. We want to factor this poly, x squared minus 2x minus 35. The goal is to figure out what two smaller binomials multiplied together to make the polynomial on top. It's going to be x plus something times x plus something. Or maybe noticing that our c value is negative 35, that means that one of my binomials at the bottom is plus and the other is minus. So we know that already. So that's our goal, is what are these two numbers? Start by making your list. What numbers multiply to make negative 35? Multiplies to negative 35. And then adds to negative 2. 1 times 35. Try 2. 35 divided by 2 doesn't give us a whole number. Divided by 3 doesn't give us a whole number. When we get to 5, it'll work. 5 times 7. And if you notice the space between 5 and 7 is 2, that means we're on the right track. Then we got to decide which one is positive, which one is negative. So how do we know which one we want to make positive here? We know they need to add up to negative 2. Can anyone help me with that decision? Should we make the 5 negative or the 7 negative?
The 7.
Absolutely. Who was that?
Manaya.
Manaya, thank you. Now, how do you know it's the 7 and not the 5, please?
Because when you add the two numbers up, you get a negative 2, and then you multiply it, and divide it, my bad, divide it,
That's right.
and you get 7.
Okay. So, yeah, you're right on. So it's going to be a positive 5 and a negative 7. So this time I'm not going to do the skipping thing, but I think we could do the skipping steps like Aaron pointed out. Let's just, you know what, let's do it. And then I'm going to work it out like I have been. So positive 5, x plus 5 times x minus 7. So that should be our answer. And if we work it out the whole way, let's work it out the whole way like we did before to see that in action. So I'm rewriting our original at the top. But instead of minus 2x, it's going to become plus 5x minus 7x. And then minus 35. And then we do the individual factoring, the first two terms, the last two terms. We can pull out x from the first two. We get x plus 5. Cool. Now in the next two terms, this is kind of cool. They're both negative. So it's easier to see this time. We want to pull out negative 7. Notice that the number we're pulling out from the second two terms, the negative 7x, negative 35, you've probably noticed by now what we're pulling out or factoring out is always this coefficient. So whatever that is what's coming out. Negative 7. And hopefully negative 35, here side work, negative 35 divided by negative 7, we want that to be a plus 5. Double check it in your calculator. Very good. Negative divided by negative does give positive, and 35 divided by 7 is 5. We kind of knew that earlier from making our list, but just in case, check your work as you're doing it. Cool. And it's coming out exactly like we thought it would from our guess earlier, our skipping of the steps. Very good. X plus 5 times x minus 7.
Wait, I have a question. So
Please.
what did we do to get the 7 to become negative again? I'm not understanding.
At Do you mean from when we first? Let me do this. I'm going to label these lines, okay? So I'm going to label it line 1, 2, 3, and 4. Do you mean back here in line 2 when we first wrote the negative 7x?
Yeah, like that, or when we had to multiply to get 35.
Okay,
How I forgot how we got.
it's okay. Thanks for asking. So it's a good question. How do we know to make the 7 negative? Um, we know that we're going to multiply two numbers and they got to be 35. I like to go through and just do it positive, right? Like 1 times 35, and then I got to 5 times 7. That makes 35. So I know I'm on the right track. But plot twist, one of them has to be negative because of this. Um, any number times another number, if they equal a negative when I multiply them, a times b, that means one of these has to be negative. And so I know, okay, well, I just found 5 and 7. Those multiply to make negative 35. But how do I know which one I want to be negative? That comes from the second part of our list making. We know that when we add together our 5 and 7, they have to make our b value in the middle, the negative 2. So I do this. I say 5 minus 7. What does that equal? And then I'm going to switch the signs, Braden, and say negative 5 plus 7. So test it out both ways. One should give us 2, and one will give us negative 2. 5 minus 7 gives us the negative 2. Negative 5 plus 7 gives us the positive 2. And we want to pick the mix, the one like the set of these 5 or negative 7, negative 5 or positive 7 that gives us the whatever the b value was in our problem, in our polynomial.
Okay.
So it's like there's a lot of different logical things going, like decisions going on here. From the very beginning, let me change my color here. From the very beginning, we knew we have to have two numbers. One of them is going to be negative. And how do we know that? Because the 35 is negative. So right kind of from the very beginning, because of this, we know that one of these numbers is going to be negative, one's positive. Then we found the actual numbers, 5 and 7, by like just dividing everything from 35 until we got the mix that multiplies to 35. And they added up to a 2. Or like when we subtracted them one from the other, we get a 2 or a negative 2, which is on the right track. Because that's what our B number was in the middle.
Oh, okay.
So we have to, that's why B is important. It's like how come it wasn't 1 and 35? How come it wasn't this set? Well, because if I add these together or subtract these together, hope you can see that this is going to be negative 34 and then positive 34. And so we know we're not going to use the 1 and 35 to split up B because we want it to be a negative 2. So we know right away, okay, we can skip the 1 and 35 mix. We're going to use the 5 and 7 mix because they lead us to that middle term properly, the one that we started with in our problem.
Okay.
Does that help, or did I just make it worse?
No, you didn't make it worse.
Okay.
Still, yeah, I'm still getting there though.
Let's do another one. Any other questions on example 3 right now?
I have a question.
Yeah, Manaya.
Do it matter which order you write it in? Like, if you write x negative 7 times x plus 5, would that be wrong?
No, it wouldn't. And in fact, let's do it right now real quick if that's okay. Can I show you?
Yeah, sure.
Totally. Let's do it. So this is gonna be like example 3, part 2. Instead of doing the 5x first, we'll do the negative 7x first. So not a new example. Let's just say we did our list. We found our negative 7 and our positive 5. And I wrote it this way instead of how we did it originally. So just notice all I'm doing is swapping the 7x and the 5x, right? Negative 7, positive 5. I just swapped their positions. I didn't change the sign. Like 7's still negative because when I add those, we want it to be a negative 2. All right, so now we factor the front 2 and the back 2. Here we're pulling out x, and what's left is x minus 7. On the right, we pull out a positive 5. Basically, it's whatever that coefficient is of the x. And we're left with negative 7. Now we pull out the x minus 7, and we have left over x plus 5. This is the same as what we got previously. The only difference is they're written like in reverse, but that's okay because they're being multiplied. So the order that we multiply things doesn't change their outcome. So these are equivalent to each other. How we solved the problem looked a little different because we pulled out the 5 this time. We factored out the 5 instead of the minus 7 like we did the first time. So, good question, Manaya. Feel free to write it either way. What's important is finding the right numbers, like Braden was talking about. We got to find the 7 and the 5, and then we had to decide which one's negative, which one's positive. And once we make it that far, it's okay no matter how we choose to write it, how we choose to split it up. Does that help, Manaya, or not yet?
Yeah, that helps.
Okay. Let's try number 4. New one. All right, here we go. X to the second power minus 16x plus 63. All right, so before we even look at our list, folks, one of these terms is negative, right? B is negative here. So that's a clue that we're going to have something negative for our two terms that we find, our two numbers that we find. When we multiply them, it's positive 63. So remember, if two numbers multiply and make a positive, that means they're either both positive or they're both negative. If we're adding the two numbers and they're negative, that means they have to both be negative. So before we've even done any list making, we know that both numbers will be negative. You can't multiply two numbers and get a positive and have only one of the numbers be negative. That means they're either both positive numbers or both negatives. So multiply to 63 adds to negative 16. One times 63. Even though we're probably never going to choose that first option, I like to start with it. 63 divided by 2 doesn't work. 63 divided by 3 is 21. So 3 times 21. Maybe that's our answer. So to find out, let's try subtracting 21 minus 3. And the difference is 18, not 16. It's really close, but that eliminates it. It's not our answer. Let's keep looking. 63 divided by 4 doesn't work. 5 doesn't work. 6 doesn't work. 63 divided by 7? 7 and 9. 7 times 9. Now, earlier I was talking about the negative business, and since 63 is positive and the 16 is negative, that means we know both of our numbers have to be negative. So let's try this out. Negative 7 combined with a negative 9. Sure enough, it does give us negative 16. So there's the configuration we pick to break up our b. So we write it again here. X to the second power minus 7x minus 9x. Notice that the 7x, 9x, that comes from the 16 plus 63. Okay. On the left, it's, I think, pretty easy factoring. What can I take from x squared and 7x? It's only a single x. Very good. And x minus 7 is left over. On the right, things are a little weird again because the negative's in the wrong spot. So when that happens, I want you to pull out negative the coefficient, negative 9. Because we want it to match with our other parenthesis. We want it to be x minus 7. If we only pull out 9, we would get this. Write it above. And we don't want it to be negative x plus 7. So to fix that, we're pulling out negative 9 instead. So pull out negative 9, not positive 9. And then from here, we're basically done x minus 7 times x minus 9. And of course, we could have done the shortcut that Aaron pointed out today. As soon as we found negative 7, negative 9, we can cut to the end and say, okay, it's going to be x minus 7 times x minus 9. But that trick will only work when a is equal to 1. All of yesterday's work and today's work, and when we do our mastery test, which I'd like to do right now, we're going to have problems where a is equal to 1. So we can do the shortcut. Any questions on example 4? No questions. Oh.
No.
Okay. There's one thing I didn't mention yet. Let me just show it to you quick. We've been doing factoring. I think we started it on, well, I guess it was Tuesday. We started basic factoring. And we've been doing it in all these problems when we, at this stage, are like pulling out or factoring out things from the first two set and the last two numbers. Quick side example, x squared minus 10x. So when we are dividing out what we can from x squared minus 10x, and we pull out, okay, I can pull out an x, and what's left is x minus 10. What we call what we divided out right here, this is called the greatest common factor. So what we can factor out of two or more terms, like we've been doing this whole week, there's a technical name for that, and it's called the GCF, or the greatest common factor. I noticed in the mastery test, they mentioned the GCF a few times. So you've been using it all week. We just didn't call it that. Greatest common factor. When you look at a set of or a string of terms and you want to factor stuff out, you're looking for the biggest number, the greatest, that's common between all the different terms. Greatest common factor. Let's look at another quick side example for greatest common factor. Remember, we've been doing this all week. Let's make a more complicated one. Let's do 50 x to the third minus 25 x to the second. What is the GCF? What is the greatest common factor? In other words, what can we factor out of these?
$25.
Okay, very good. Yeah, I can take out 25. How about x's? What's the most number, the greatest common number of x's I could take out?
2.
2. And we say that as x to the second or x squared. Good. So for this example, the GCF, and thank you for helping me out, is 25x to the second power. And it just turns out that's this entire term, right? So that doesn't always happen. But this was the most we could take out for number, the 25, and for x's or for variables. So if you get a question today in the mastery test about greatest common factor, this is all they mean, is like what's the most that we could factor out from these terms that they gave us. All right, so it's 10:40 now. What I'd like everyone to do is go into Admentum and hang on a sec. Go into Admentum and let's do the mastery test in Unit 2 called Factoring Polynomials Part 1. Part 1. 5 questions, of course. And if you want to ask about a question you get, just tell me. And you can either share your screen to show me the question, or you can just read it to me and I'll find it. But let's use this 20 minutes to try to get done the whole test together today. It's only 5 questions, so it should be enough time to get it done.